Hi guys, so my name is Peter C. Dokwa Jr., math instructor at the University of Liberia and your tutorial teacher. So in this video, I want to look at the derivative of tangent of x using the first principle of derivative or the definition of derivative. So we're going to see how best we can easily, please don't be factoring because it's very easy, how we can easily find the derivative of tangent of x using the first principle. So let's get started. So we have within the first principle of derivative formula f of x and f of x plus h. Already we know that f of x, according to the problem, is tangent of x. This is f of x, right? So the next thing we need to know is f of x plus h. What is f of x plus h? So f of x plus h now is like replacing x with x plus h. So anywhere I see x on the left, the right hand side, I'm going to replace it with x plus h. So I've gotten f of x and I've gotten f of x plus h. Now let me replace it in the formula. So I will have the limit. So this one now, f of x plus h minus f of x all over h approaches 0. So you have the limit. So this first expression now is tangent or tan x plus h minus tan of x as x approaches 0. So our next target again is to expand tangent of x plus h. And according to the identity, the tangent of a sum identity, we know that tangent of x plus h or tangent of a plus b or tangent of x plus y is just equal to 1, or not 1, but tangent of x plus tangent of h, all divided by 1 minus tangent of x times tangent of h minus tangent of x. We express this over 1, and this whole thing is being divided by h as h is approaching 0. So we have the derivative, the limit now. So we can simplify the numerator. So we can say the tangent of x plus tangent of h. Now let's find the LCD for it. So within the entire numerator, the LCD there now is tangent 1 minus tangent of x tangent of h times 1. So it's just the same as 1 minus tangent of x tangent of h. So this expression goes into this is just 1 times this numerator is the same thing. So it's tangent of x plus tangent of h. Minus 1 goes into this one is just the same thing. So it is this entire thing you're going to multiply by tangent of x. So you're going to say tangent of x times 1 minus tangent of x tangent of h. Now remember, you have a denominator expression divided by h. So we can further simplify it by multiplying that. So we have tangent of x plus tangent of h minus tangent of x plus negative and negative is positive tangent square x times tangent of h, all divided by 1 minus tangent of x tangent of h. So this one, carry this one out as h approaches 0. So what are we left with? So we are left with the derivative equals to the limit of tangent of h plus tangent square x tangent of h, all divided by 1 minus tangent of x tangent of h, times we can reciprocate and make this to be 1 over h. So what do we observe? We notice that there is some similarities, right? So we can do some factoring. So f prime of x is equals to the limit. We can factor out tangent of h. Then we are left with 1 plus tangent square x all over h, bring this h, then we say times 1 minus tangent of x tangent of h, as h is approaching 0. So now we have f prime of x is equals to tangent of h all over h. So tangent of h all over h, remember, according to the squeeze theorem, the limit of tangent of h over h as h approaches 0 is equals to 1. So we can extract this portion, h approaches 0, and then we take the limit of the remaining portion, which is 1 plus tangent square x all over 1 minus tangent of x tangent of h, as h approaches 0. So now f prime of x is just equal to tangent, the limit of tangent of x all over this is just 1 times, for this now we can apply the limit. So you have 1 plus tangent of tangent square x all over 1 minus tangent of x times tangent of 0. And tangent of 0, tangent, we know that tangent of x is equal to sine of x all over cos of x. So tangent now of 0 will be equal to sine of 0 all over cos of 0. And sine of 0 is equal to 0, while cos of 0 is equal to 1. So this is just equal to 0. So tangent of 0 is 0. So this whole thing here goes to 0. So this now will be 1 times this expression is the same thing. 1 plus tangent square x is equal to secant square x according to the Pythagorean identity, all divided by 1 minus, now tangent of x multiplied by 0, the whole thing will cancel. So it will just be secant square x all over 1. So therefore, f prime of x now is just equal to secant square x. So the derivative of tangent of x using the first principle is just equal to secant square x. And when you use even the methods of differentiation, you will still get the same secant square x. So thanks ever so much for watching. See you next class.